In addition, hyperthermic conditioning can help you maintain your lean muscle mass by 3 mechanisms. The induction of heat shock proteins, which I'll get to in a minute, and this is where the gene expression comes in, and this is also where I'm going to talk about hormesis. And also through the induction of growth hormone, and by improving insulin sensitivity. So let's start off with the heat shock proteins. So heat causes heat stress, and the response in your body to this heat stress is to increase the expression of genes that make something called heat shock proteins. And this is really a prime example of hormesis. So where you apply stress, so heat is a form of stress, exercise is also a form of stress, you're also elevating your core body temperature, so you're stressing your body. But there's a stress response. Your body responds to this stress that you're applying by increasing the expression of genes that can deal with stress. So it increases the expression of genes like antioxidant genes. In this case, when you apply heat stress, it increases the expression of genes that make heat shock proteins. And heat shock proteins are pretty awesome because they repair damaged proteins. So they help these proteins in your body are what are doing all the work. And they repair proteins that are damaged to make sure that they have their proper structure. You need your proteins to have their proper structure in order to do what they're supposed to do. And they also prevent oxidative stress. So they scavenge free radicals, and they also increase glutathione recycling. So these heat shock proteins, HSPs, are very, very important and also a really cool hormetic response to heat that can help your body deal with stress. And what's interesting is that they also, because they can repair damaged proteins and prevent oxidative stress, they prevent the degradation of proteins because both oxidized proteins get degraded, and also proteins that are not that are damaged, that are not in their proper structure, they also get degraded. So what ends up happening is that heat shock proteins can cause a net increase in protein synthesis, which if we're looking in a muscle cell is kind of important. If you're trying to maintain muscle mass or even gain muscle mass, you obviously need to apply a workforce or apply a workload during whatever sort of physical activity that is, and also you need to have a net protein synthesis gain, which is also important. So when you hyperthermically condition your body to heat stress through the sauna, what ends up happening is that under normal temperatures, so when you're done with the sauna under normal temperatures, you actually have a higher expression of these genes and these heat shock proteins just under normal temperatures. And then what happens is later on, when you increase your core body temperature, when you're exercising, you have an even higher level of these heat shock proteins. So let's talk about what this means functionally. So in mice that were subjected to 30-minute, I guess kind of a sauna session for mouse, they put them in a little chamber. It's called whole body hyperthermia for 30 minutes. And they did this every other day for a week. And what they found is that when they made these mice, they immobilized them. They put a little cast on their little hind legs so they couldn't move for a week. And then they took the cast off and let them move around again. So they were then, this reintroduction to exercise usually causes a big burst in oxidative stress. But what they found is that these mice actually had a 30% increase in the regrowth in their soleus muscle, and that corresponded with an increase in HSP70, heat shock protein 70. So and this was compared to the mice that were not hypothermically conditioned. So these mice that were hypothermically conditioned, high expression of HSP70, the other ones didn't, and they also regrew the 30% more of their soleus muscle.